Welcome learners. In this lecture we are going to discuss properties of mean, relationship between AM, GM and HM and properties of standard deviation. The learning objective of this lecture is to discuss different properties of mean and to derive the relationship between AM, GM and HM. That is AM is greater than GM is greater than HM and GM square is equal to AM into HM, and we will discuss some properties of standard deviation. Okay, the first property of arithmetic mean is the algebraic sum of deviations of the observations taken from their mean is 0. The arithmetic mean is given by x bar is equal to I is equal to 1 to n xi by n in case of raw data. Here from this n into x bar is equal to summation I is equal to 1 to n xi is equal to n into x bar. This is I is equal to 1 to n xi minus x bar. This is the sum of deviations taken from their arithmetic mean. This is 0. We have to prove this equation. Also, in case of frequency distribution, we have I is equal to 1 to n fi into xi minus x bar is equal to 0. Let us look at this equation. First, take summation inside the bracket. Summation I is equal to 1 to n xi and summation I is equal to 1 to n xi bar x bar. This is equal to I is equal to 1 to n xi minus, this is summation over a constant. We know that the summation over a constant is constant n times the constant. So this is n into x bar. So this is summation I is equal to 1 to n xi. This n and n gets cancelled. I is equal to 1 to n remains. That is equal to 0. Similarly, for frequency distribution, x bar is equal to I is equal to 1 to n fi fx by n. From this, I sigma fx is equal to n into x bar. Here also take this equation I is equal to 1 to n fi xi minus x bar is equal to, take summation fi inside, summation fi xi minus summation fi into x bar. We know that I is equal to 1 to n fx is equal to n into x bar. Instead of this, we can use n into x bar. Here I is equal to 1 to n fi is nothing but total frequency, that is n. This is equal to n into x bar, that is equal to 0. We can prove in these two ways also. So hence the algebraic sum of deviations from their mean is 0. Next property is sum of squares of deviations of a set of values is minimum. Sum of squares of observations from their mean is minimum, whereas sum of squares of observations is 0. Sum of squares of observations is minimum when taken from their mean. Here let xi fi be the frequency distribution of variable x and f. Here x is repeated f times, xi repeated fi times, and also let the z is function. This is I is equal to 1 to n fi xi minus a whole square. This is nothing but the sum of squares of deviations taken from an arbitrary value a or arbitrary point a. Now we have to prove that this function z is minimum, and this z is minimum when a is equal to x bar. This is the property, and we know that the function z has minimum value if dou z by dou a is equal to 0. Here a is the value, arbitrary value. If dou z dz by dA is equal to 0, then the function z has minimum value, and According to maximum and minima, the dou z square by dou a square also must be greater than 0. To prove that a function is minimum, the function has to satisfy these two conditions. So let us look at the function dou z by dou a first. This is equal to 0. This must be equal to 0. This implies dou a by dou d by dA of this function. This function I is equal to 1 to n fi xi minus a whole square. By applying derivative, this 2 becomes here, and d by dA of a is minus 1. So minus 1 into 2 is minus 2, and this is I is equal to 1 to n fi xi minus a remains here. This is equal to 0. And this minus 2 goes right hand side, becomes 0. I is equal to 1 to n fi xi minus a is equal to 0. Take summation fi inside, I is equal to 1 to n fi xi minus a into I is equal to 1 to n fi. This I is equal to 1 to n fi nothing but n total frequency. This is equal to a is equal to, this goes right hand side, plus I is equal to 1 to n fi xi. This n divides here. So this a is equal to 1 by n, I is equal to 1 to n fi xi, nothing but mean. So a is equal to mean. When a is equal to mean, this function has minimum value. Let us look at the second point also, second condition also. Dou square z by dou a square is equal to dou by dou a into dou by dou z by dou a. This dou z by dou a we have already derived, minus 2 into I is equal to 1 to n fi xi minus a. By applying derivative on this function, here this minus 2 dou a dou dA by dA is equal to minus 1. d by dx of x is equal to minus 1, constant. So this is minus 1. Minus 1 into minus 1 plus 2, minus 1 into 2 plus 2, I is equal to 1 to n fi remains here. We know that this is nothing but total frequency capital N. This frequency means number of observations, the number of times the variable repeated. So it should not be negative. So this must be positive. So these two conditions is satisfied. So the minimum value of a is x bar, and the sum of squares of deviations of a set of values is minimum when they are taken about their mean. And the next property is mean of composite series or combined mean. Let x1, x2, x1 bar, x2 bar, xk bar are the means of k data series of sizes n1, n2, nk respectively. Then the mean of composite series is given by x double bar is equal to n1 x1 bar plus n2 x2 bar plus so on nk xk bar by n1 plus n2 plus nk. This is nothing but I is equal to 1 to k ni xi bar divided by I is equal to 1 to k ni xi I is equal to 1 to k ni. Or for example, x1 bar is the minimum mean of n1 observations and x2 bar is the mean of n2 observations. Then the mean of combined series is given by x double bar is equal to n1 x1 bar plus n2 x2 bar by n1 plus n2. Next concept is weighted arithmetic mean. The arithmetic mean is computed using different formulae with the assumption that all the distributions are equal importance. But in practice, we come across situations where the relative importance of items are not the same for all the items. So, for example, among the food items, the rice is more important than cashew nuts. We purchase rice every month. We purchase medicines if there is any sugar patient or BP patients in our house. We must purchase sugar. So we must purchase uh, medicines every month. So we are giving weightage to some items and we are not giving weightage to some items. So we are not giving cashew nuts weightage for cashew nuts every month. So the distribution may more important than we give some items more important than some other items. So in that case, AM will not be a proper representative of the distribution. Hence, weights are attached to each item proportional to their importance. And a new average is obtained, nothing but weighted average. The new average computed on the basis of weights is known as weighted arithmetic mean. And here this W1, W2, Wn are the weights attached to the variable values x1, x2, xn. Here x1, x2, xn are the variables and here these are the weights attached to that variable. And the weighted arithmetic mean is given by x bar w is equal to w1 x1 plus w2 x2 plus so on wn xn divided by w1 plus w2 plus wn. These are the weights. This is equal to summation wi xi by sigma w. This is nothing but the frequency sigma fi xi by sigma fi. Here we call it as weights. In one examination they are asked about the weighted arithmetic mean also. So you need to write this answer. For 5 marks they are asked. And some there are some other means also. They are in some competitive examinations I found they are asking about root mean square. Root mean square is derived from mean only. Look here. This is here every observation is squared and added divided by the number of observations and root is applied. So for mean we add the observations and divided by the number of observations simply. Here every observation is square and divided by the number of observations and root is applied. So this is called root mean square. Generally this root mean square is greater than the arithmetic mean. There is another moving average also there. Another average is moving average. Here the moving average is calculated by this method. Here we have 5 observations. Here we have number of observations. We add first 5 observations divided by that 5 and leave the first value and add the second 5 observations. So this is also one type of average which is used to calculate moving averages in time series. Now we discuss the properties of standard deviation. The following are the some important properties of standard deviation. The standard deviation is invariant, unchanged under change of origin. If we add or subtract any values from the variable, the standard deviation does not change. But the standard deviation is not invariant under the change of scale. If we multiply or divide the variable with an arbitrary value, then accordingly the standard deviation also change. The value of standard deviation is always positive. And the standard deviation always less than or equal to the range. It should not be greater than range. For a symmetric frequency distribution, this is the most important property of standard deviation, and the relationship between mean and standard deviation decides the shape of frequency curve, symmetrical frequency curve, normal frequency curve. Suppose x bar is the mean and sigma is the standard deviation, then the 68.27% of the area covered under plus or minus x bar and sigma. Similarly, 95.44% of the area should be covered by x bar plus or minus 2 sigma. Here, similarly, x bar plus or minus 3 sigma covers 99.73% of the observations in the given data. Okay, The interval is better than other two intervals. The third interval is better than other. This is the called area property. This is called as area property. Look here. Here in the middle, x bar minus the standard deviation, x bar plus standard deviation covers 68%, approximately 68%. X bar minus 2 sigma, x bar plus 2 sigma. This area is 95.44%. And x bar minus 3 sigma, x bar plus 3 sigma covers 99.73%. This is most important property of standard deviation. The arithmetic mean of first n natural numbers is n plus 1 by 2. We know that the sum of n natural numbers is n plus 1 by 2, and the mean of first n natural numbers is n plus 1 by 2 by 2 into n, since there are n observations. N into n plus 1 by 2, the n and n gets cancelled, n plus 1 by 2 remains. So the arithmetic mean of first n natural numbers is n plus 1 by 2. Similarly, the standard deviation of first n natural numbers is root of n square minus 1 by 12, or the variance of first n natural numbers is n square minus 1 by 12. The combined standard deviation also calculated. Suppose if sigma 1 is the standard sigma 1 square is the variance of first two observations, we can find the combined standard deviation like this. D is equal to x1 bar minus x double bar. X double bar is the combined average. Okay, these are the properties of standard deviation. Now let us derive the relationship between AM, GM and HM. In one examination, they asked to prove the relationship between AM, GM and HM. In the point of competitive point of view also, this is very important. We can prove this with a simple technique. Let A and B be two real numbers. They are positive numbers. Then arithmetic mean is sum of observations by number of observations, A plus B by 2. GM is the product of their observations, the nth root of product of n observations. So here we have two observations. Nth second root is AB into 1 by 2. This is equal to nothing but root of AB. And the harmonic mean is the reciprocal of arithmetic mean of reciprocals of arithmetic mean. The reciprocal of arithmetic mean of reciprocals. The reciprocals are 1 by A and 1 by B. Arithmetic mean of reciprocals is 1 by A plus 1 by B by 2. This is HM is reciprocals of arithmetic mean. So this becomes, this 2 multiplies the numerator, 2 by 1 by A plus 1 by B. Here 2 by this AB and B plus A by AB. And this is nothing but this AB again multiplies this 2 and 2AB by A plus B. For any two observations, there is AM is A plus B by 2, GM is root of AB, HM is 2AB by A plus B. Now consider root A minus root B whole square. Here the difference is squared. These two are real numbers. Real numbers again squared. So this must be a positive value. So expand this A minus B whole square. A square minus root A whole square, nothing but root square get cancelled, A remains. A plus B minus 2AB. So this is greater than or equal to 0. And from this AB, this minus 2 root AB goes right hand side. AB, A plus B greater than or equal to 2 into root AB. That this is third equation. And from this, this 2 divides the LHS. A plus B by 2 greater than or equal to root of AB. Here A plus B is AM, root AB is GM, AM greater than or equal to G. This is fourth equation. Now multiply this equation 3. This is equation 3 with root AB on both sides. What happened? root AB into A plus B, this greater than or equal to 2 into root AB, root AB. Root AB into A plus B greater than or equal to root of AB into root of AB, nothing but 2 into AB. This implies root AB greater than or equal to this A plus B in RHS, it divides 2AB. Look here, this root AB is GM, this is HM, so GM greater than or equal to HM. And from equation 4, by using equation 4, we have AM greater than GM. Here GM greater than HM. So AM greater than GM greater than HM. This is the proof of relationship between AM greater than GM greater than HM. Also, there is another relationship, GM square is equal to AM into GM. Here, this is, we know, take this one, AB, root AB squared. What happened? This becomes AB. Look here, this AB gets cancelled, 2 gets cancelled, AB remains. This is square of GM is equal to AM into HM. By using this relationship, we can find AM or GM or HM when two observations are given. Okay. In this video lecture, we have discussed the properties of arithmetic mean, properties of standard deviation, and different types of moments, root, mean, square, and moving average. Also, we have discussed the relationship between AM, GM, and HM. Thank you.